There is an outline of a black hollow that does not involve gravity. Simplest entails quantum mechanics. Black holes are cosmic chasms that consume the entirety of their course, including light itself. Those cosmic giants, which had been formed from the remnants of significant stars, have gravitational pull so strong that they distort space and time, entangling everything within their gravitational hold, including time itself. Now, a discovery exposed through the James Webb Telescope challenges the essential bits of our understanding. A dormant black hollow that is only a few mild years far from our solar system. Lying in the depths of space, it's as if nature itself is gambling a cosmic recreation of disguise and are searching for, concealing these celestial monsters in the innermost recesses of the universe. Just how does this discovery cast doubt on our long-held ideals of how galaxies came to be? Does this cosmic aberration pose a danger to Earth? So, be a part of us as we explore how the James Webb Telescope just detected a massive, dormant black hole close to the solar device. Black holes are a tricky bunch. It became quite a challenge to search for the first one. Even though Einstein's principle of relativity predicted that they had been common, black holes, in comparison to stars, do not give off any mild on their own, making their size and spin the simplest properties that can be measured approximately them. We have photographic evidence of black holes. Thus, we understand they exist. But conclusive evidence of black holes has been missing for quite a while. For scientists, Cygnus X1 was the first to be found in 1964. Stephen Hawking and Kip Thorne, two of the most government on black holes, did not attain a consensus on whether Cygnus X1 changed into certainly a black hollow until over 30 years later. Hawking becomes pretty certain that black holes did, in reality, exist. They have been, in any case, a critical emphasis of his expert lifestyles. But the query of whether or not scientists ought to surely find one remained unanswered. Certainly, Hawking becomes a little traumatic about the shortage of findings, so he hedged his bets with his research. Additionally, he mentions that he and Thorne were almost wonderful that Cygnus X1 was a black hole in 1975. Whilst the wager become to begin with forged, they were each 95% positive by means of 1988, according to Hawking. Nonetheless, they got here to in settlement the bet could not be finalized till they had been each clearly sure. Hawking became compelled to relinquish the bet in 1990, whilst more observations of the system had gathered enough proof that it contained a black hollow. Thorne claims that Hawking waited for the proper time to concede defeat. 2 gear counters were released into area on a suborbital rocket, which caused the preliminary discovery of Cygnus X1. A sign turned into detected by the gear counters, which astronomers had been able to pinpoint to a device 7,200 light-years away, presenting a blue notable giant star surrounding another big item. The second one object they decided was additionally strongly radiating X-rays, which could make experience if it had been a black hole. Much research has targeted on Cygnus X1 since it was determined in 1964, the first black hole within the universe. However, it has more surprises in shop for scientists. New studies suggest that the black hole is, in reality, 21 times the mass of the Sun. This object has the difference of being the most important stellar mass black hole that has ever been observed without the utilization of gravitational waves. This new finding, say the researchers, casts doubt on astronomers' lengthy-held assumptions, approximately black hole formation. The stellar winds that blow from a star's floor motive the superstar to lose mass to its environment. But if we need a black hole this massive, we should reduce the mass loss experienced through amazing stars over their lifetimes. Cygnus X1 breaks information in extra ways than one. Its superb bulk is best considered one of them. Cygnus X1 has the fastest rotational speed of any black hole found up to now, drawing near the velocity of mild. A black hole with this kind of excessive spin also does not follow the familiar sample of black hole evolution. Despite the fact that definitive proof of black holes has best just been discovered, it is turning into more and more apparent that they are scattered over the universe. Therefore, even if astronomers finally untangle all the mysteries of Cygnus X1, the primary of its kind, its endless can surely still hold many surprises. Less than 2,000 light-years far away from Earth, scientists have observed a slumbering massive, the Milky Way's largest stellar black hole with a mass 33 times more than that of our Sun. No matter being the second closest recognized black hole to Earth, the dormant JWST had remained undiscovered. Found by way of twist of fate in a deluge of data and observations collected by means of scientists from the European Space Agency, JWST is located in the constellation Ala, the Eagle. The organization noticed something out of the regular as they went through information from the agency's Gaia task, which is creating a three-dimensional map of our galaxy. A star that was wobbling 1,926 mild-years distant. The peculiar trajectory of the object pointed to its being ensnared in an orbit with the aid of a neighboring big black hole. To confirm the mass of JWST, the astronomers and floor operators make use of the very large telescope of the European Southern Observatory in Chile to validate their discovery. They discovered that once every 11.6 years, the wobbling megastar completes one orbit across the black hole. The discovery of the nearby undetected excessive mass black hole came as a complete wonder to everyone. JWST is a type of black hole because of the crumble of a star called a stellar black hole, and it is the largest of this type located in our galaxy. As a dormant black hole, it isn't always actively siphoning energy and materials from a companion star, making it inconspicuous in surveys of the sky. Stellar black holes in our Milky Way normally have a mass around 10 times that of the solar, with Cygnus X1 holding the record at 21 times the solar's mass. JWST, which has a mass of 33 sun masses, continues to be tiny in evaluation to all black holes. For instance, the central great massive black hole in our galaxy, Sagittarius A*, is 4 million instances larger than the Sun. JWST is the second closest black hole to Earth, behind only JWST, that is 1,500 mild-years away and 10 times the mass of the Sun. Astronomers now have greater proof to piece together how stellar black holes formed from the loss of life of lengthion stars, which makes the invention all the more essential. Stars with lower concentrations of heavy metals are thought by astronomers to be the source of greater massive stellar black holes. Theoretically, these metal-poor stars, which can be especially product of hydrogen and helium, are believed to enjoy slower mass loss, leaving more fabric available to create more massive black holes when they die. However, scientists did not have an example to draw from till they located JWST and its companion big name, which became metal-poor, indicating that the famous person that generated the black hollow turned into likewise low in metal. Alternatively, the use of the James Webb Space Telescope, astronomers have found an exceptionally red, great big black hole growing in the early universe's shadow. Because the universe expanded, the great massive black hole took on a reddish color. This turned into a few 700 million years after the massive bang. As the universe expands in every direction, the mild entering into our path is redshifted. And in this example, the redshifted mild indicates a thick veil of fuel and dirt surrounding the black hole. Lucas Farrow and Addis Zitron of the Bern University of an astronomy crew had been capable of establishing the awesome massive black hole's mass by studying JWST facts. Its startling massiveness at approximately 40 million times the Sun's mass stands in stark evaluation to the galaxy it inhabits. Additionally, the organization located that the exceptional massive black hole is fast devouring the dust and gasoline surrounding it. It is situated about 12.9 billion mild-years from Earth. Located clearly, its expanding scientists instantly suspected it was a quasar-like object because of its red dot appearance. Quasars are created when copious quantities of B-counted surround notable massive black holes like this one. This matter forms a disk of gasoline and dirt called an accretion disk that progressively feeds the black hole. The tremendous gravitational effect of the black hole churns this producing intense temperatures and causing it to glow. Moreover, the cosmic titan's poles obtain any cloth that doesn't fall into the tremendous massive black hole, using highly columnated jets. Debris in these regions is propelled to speeds near the velocity of mild, and bright electromagnetic emissions accompany the eruptions as these relativistic jets are shot forth. Exceptional massive black holes in active galactic IC nuclei AGN generate quasars, which are so extreme that their brightness exceeds that of all the stars in their surrounding galaxy. Putting JWST information, this exceptional massive black hole looked like a tiny point because of the big quantity of radiation it was emitting. The item changed into determined to be an unusual star-forming galaxy based totally on coloration evaluation. This supplied extra proof in favor of the concept of exceptional massive black holes. Its small size and apparent exceptional massive black hollow nature stood out from the opposite quasars located in those early days. In spite of JWST's powerful infrared eye, the early quasar wouldn't have been visible if it weren't for the mild entering the first detection. Its uncommon luminous measurements prompted researchers to check the facts for cosmic echoes, discovering one's JB. To at least the last 700 million years on various scales, the object has reflected a number of the emitted emissions from nearby luminous quasars, making it some of the longest-lasting and remaining of the moving cosmic bodies. The echo is captured after the movement follows it. Like the data to find hole was they holes black so data which years. The discovery of the peculiar source, named 1SJ0704 plus 1000, raised eyebrows among astronomers. Its unusual luminosity and spectral characteristics prompted researchers to scrutinize the data for potential cosmic echoes. They discovered that over the last 700 million years, this object has intermittently reflected emissions from nearby luminous quasars, making it one of the longest-lasting and most reflective cosmic bodies observed. This echo phenomenon suggests that the object, likely a black hole, has been in motion relative to these quasars over cosmic timescales. Such observations provide invaluable insights into the dynamics and interactions within galaxies and their environments, shedding light on the evolution of massive cosmic structures. The discovery of the peculiar source, named 1SJ0704 plus 1000, initially baffled astronomers due to its unusual luminosity and spectral characteristics. Upon closer examination of the data, researchers identified a fascinating phenomenon. Over the past 700 million years, this object has periodically exhibited a phenomenon known as cosmic echoing. This means that it has intermittently reflected emissions originating from nearby luminous quasars. The implications of this cosmic echo are profound. It suggests that 1SJ0704 plus 1000, likely a black hole or another highly energetic object, has been moving relative to these quasars over immense timescales. This movement not only indicates dynamic interactions within its galactic environment, but also provides a glimpse into the complex evolution of cosmic structures. Further studies and analysis of such phenomena are crucial for understanding the formation, growth, and interactions of massive objects in the universe. They contribute significantly to our broader knowledge of astrophysics and cosmology, revealing insights into how galaxies evolve and interact over cosmic epochs. The discovery of 1SJ0704 plus 1000, a peculiar cosmic source exhibiting unusual luminosity and spectral characteristics, has captivated astronomers and cosmologists alike. This object's unique behavior, particularly its intermittent reflection of emissions from nearby luminous quasars over the past 700 million years, presents a tantalizing puzzle in the study of cosmic dynamics and evolution. Astronomers initially identified 1SJ0704 plus 1000 through detailed observations using advanced telescopes and data analysis techniques. Its ability to echo emissions from quasars, distant and luminous galactic nuclei powered by supermassive black holes, suggests a dynamic interaction between this object and its surrounding cosmic environment. Quasars themselves are among the most energetic and luminous objects in the universe, often outshining entire galaxies. They emit vast amounts of energy across the electromagnetic spectrum, from radio waves to gamma rays, and their emissions can travel vast distances through space. When these emissions encounter other cosmic objects, such as intervening clouds of gas and dust or potentially 1SJ0704 plus 1000 itself, they can be scattered, absorbed, or even reflected. The phenomenon of cosmic echoing observed in 1SJ0704 plus 1000 indicates that it has been in motion relative to these quasars over millions of years. This movement is likely influenced by gravitational interactions with other objects within its galactic neighborhood or broader cosmic structures. Such interactions are crucial in shaping the evolution of galaxies and their constituent stars, gas, and dark matter. Understanding the nature and implications of cosmic echoing requires sophisticated theoretical models and observational data. Researchers employ computational simulations to reconstruct the trajectories and interactions of 1SJ0704 plus 1000 and nearby quasars over cosmic timescales. These simulations incorporate gravitational dynamics, gas dynamics, and the physics of radiation propagation to elucidate how such cosmic phenomena unfold. Moreover, observational campaigns continue to monitor 1SJ0704 plus 1000 and similar objects with cutting-edge telescopes and instruments. The James Webb Space Telescope, JWST, launched with the capability to study the universe across multiple wavelengths with unprecedented sensitivity and resolution, promises further insights into cosmic echoes and their implications for astrophysics. In addition to its observational capabilities, JWST's ability to probe the cosmic microwave background, CMB, radiation and study the early universe's formation and evolution is invaluable. By analyzing the faint echoes of the CMB left over from the Big Bang, astronomers can reconstruct the universe's early history, including the formation of the first stars, galaxies, and supermassive black holes. Back to 1SJ0704 plus 1000. Its discovery underscores the interconnectedness of cosmic phenomena across vast distances and timescales. The object's ability to reflect quasar emissions suggests a complex interplay between gravitational forces, radiation pressure, and the dynamics of interstellar and intergalactic medium. Further research avenues include investigating the nature of 1SJ0704 plus 1000 itself. Is it indeed a black hole, as hypothesized? Or could it be another exotic cosmic entity such as a neutron star or a highly active stellar remnant? Detailed spectroscopic analysis and multi-wavelength observations will provide crucial clues to unraveling its true nature and understanding its role in the broader cosmic tapestry. Moreover, the study of cosmic echoes extends beyond individual objects like 1SJ0704 plus 1000 to encompass broader questions about galaxy formation and evolution. Galaxies are not static entities but dynamic systems undergoing continuous interactions, mergers, and star formation processes. The gravitational interactions between galaxies and their satellite objects, such as dwarf galaxies and globular clusters, shape their morphology and evolution over cosmic timescales. Recent advancements in observational astronomy have revealed a rich diversity of galaxies across different epochs of the universe's history. These include distant galaxies seen as they were billions of years ago, offering insights into the early stages of galaxy formation and evolution. By studying the properties of these ancient galaxies and comparing them with their modern counterparts, astronomers can trace the evolutionary pathways that galaxies have followed over billions of years.